In this video, I want to go through a little tutorial of how to compute and draw a flow duration curve. I'm going to be doing it in Excel just because it makes it easier to see everything, but I don't expect you to be able or necessarily to have to do it in Excel. You should be able to do this by hand as well, just a little bit more tedious, and Excel makes it a little faster. So you're welcome to do it in Excel, but you don't need to. What I have here are monthly data from the year 2018 for the Suwannee River near Bell, Florida. So one is January, 12 is December, and these are the average monthly discharges in cubic feet per second. So I want to create a flow duration curve for monthly discharge of the Suwannee River. Now remember, the first thing we want to do is we want to rank these discharges from largest to smallest. So let's make these columns red to remind us that these are things we're actually going to compute here, and we're going to call that rank M. Right, and we're going to look for the largest. It's over here. That's the second largest is here. And I could go through and do this, but Excel makes it really easy to do this. I can just grab all of these data. And again, you don't have to do it this way. It's only 12 numbers, but um, it's pretty easy just to sort these by discharge from largest to smallest. And there we go. So now they're sorted, and I can just fill in these ranks from 1, the largest, to 12, the smallest. I don't really care what month these occurred in. I just have to rank the discharges from largest to smallest. Now, the next thing we're going to do is we are going to calculate our estimate of the exceedance probability, P here. And remember how P is calculated. Remember that P, I'll just write it over here, P, the exceedance probability, is defined as the rank over n plus 1, where n is the number of observations. In our case, it's going to be 12, right? We have 12 months of the year. So our first exceedance probability we would estimate as the exceedance probability for a discharge equal or exceeding 19,820 cubic feet per second will equal that rank divided by 13. And these are all going to be divided by 13 because n is 12. So in Excel, we can just write this in as this is equal to the rank, which is in cell D2 divided, there we go. And I'll express this as a percentage. Give it one more. There we go. So we can calculate all those probabilities, and there they are. Okay, so these are our exceedance probabilities for the discharges shown in column C. And now I just want to plot the probabilities versus the discharges. Now there's a fluke in Excel, which I'm going to just get around here. And the idea is, I don't need this crap here, is that in Excel, when you take two columns and graph them, by default, it takes the first column as the x-axis. And I want my probability to be on the x-axis. So I just copied my discharge over. You wouldn't have to do this if you're doing it by hand, but since I'm going to use Excel to do the graph, it helps me to make this easier. So I'm going to now insert a graph here, and it's going, let's actually do one of these. There we go. Okay. We don't need, there we go. So there is my flow duration curve here, with the y-axis being discharge in cubic feet per second and the x-axis being exceedance probability. And that actually doesn't look too bad. Often we convert this to the log. If there's a large range in discharges, and there isn't actually for this particular river. So in this case, there's no preferred format here. Whatever makes it easy to read. Sometimes we convert the y-axis to logarithmic. Sometimes we plot the x-axis on some kind of other probability type paper that spreads them out a little differently based on some kind of other transformation. But in this case, this is actually good enough. But let me show you how we would use this here. Let me just change a few things about our axis here. Whoops. There we go. Let's change the this to 0.1. so that we can see all the different numbers here. There we go. Okay, and let's put some minor. And fortunately, my version of Excel is making these super duper light. There we go. Hopefully you can see those now. All right, so let's just, so there's our flow duration curve. I guess if I really wanted to be complete, what I should do here is, let me go here and add some labels here. So this is discharge here, Q in cubic feet per second, and the x-axis is the exceedance probability in percentage. And we can see how we can use this. So, for example, the median discharge is found at 50%. So we go up here, and then that looks like that is about 6,500 or so cubic feet per second would be the median discharge of the Suwannee River. And we could also say, hey, you know that another typical value is 10%. So 10% of the time, it looks like the discharge exceeds about a little more than 18,000 cubic feet per second. So that's how we would plot a flow duration curve. Let me just show you one more thing here. Let me get rid of those annotations there. If we wanted to, we could sometimes change this axis to a logarithmic scale here. And we don't need to, we can put the minimum at 1,000 here, or else it looks kind of goofy. There we go. So this is, and let's add some, oh, we do have the minor grid lines. They're kind of hard to see here, aren't they? Let me try to make them a little bit darker if I can. I don't think I can. That's all right. So that's good enough. So anyway, this sort of makes it look a little bit more linear. So this is sometimes done, and we would make exactly the same inferences as we did before. It's just a slightly different way of plotting it. So I just wanted to just give you a quick idea of how you could actually create one of these flow duration curves. Again, I'm doing in Excel, but you don't need to. It's the same procedure. I'll give you a practice problem with a relatively small number that you can plot up and complete. So how do I turn this thing off? There we go.